All right, well, good morning, good afternoon, good evening to everybody. Whenever you're watching the videos, that's the nice thing about the videos. You can watch them whenever you want to, as long as you watch them before class, and go from there. Uh, Today we're going to talk about 6.4, chapter 6.4, section 6.4, talking about, again, factoring polynomials, because that's what we're going to be doing this whole chapter. Factoring polynomials, we're going to talk about the AC method. So 6.3, we talked about, well, we'll take a step back, I guess. 6.2, we talked about factoring polynomials of the form ax squared plus bx plus c, and a was equal to 1. We just kind of did a little bit of trial and error with 6.2 because we only had to factor one thing, and that was the c factor, because the a factor was 1. Made things pretty easy. Section 6.3 got a little bit trickier because we had a not equal to 1, and that meant that um, we had to factor not only the c factor but also the a factor, and also worry about signs and things like that. With positive and negative signs, it got a little bit trickier as well. So this section is going to talk about a method that might be easier to use. I introduced the 6.3, the trial and error method, just because I think it's going to be important. In fact, I know it's going to be important, especially for smaller ones. And in video 6. I guess take a step back. For polynomials, it'll be easier. Trial and error will be easier for polynomials where a, b, and c are relatively small. Section 6.4 is going to tell us about the AC method, which is kind of a method to, kind of a recipe, I guess, of how to solve polynomials. And it kind of gets tedious, cumbersome, and long, especially when you've got smaller polynomials with small a's and b's and c's. It just takes quite a few more steps. So I recommend, we'll do a compare and contrast later on of the trial and error versus this method, the AC method, to see which one is better at what time. But for right now, let's just kind of introduce the AC method. So I'll go up here and minimize that. We'll go to our Smartboard presentation here, 6.4, factoring using the AC method. So we talked about 6.2 and 6.3 in the previous slide. So now we're going to talk about the AC method, and again, I kind of talked about this already in the previous slide. AC method uses a route kind of in a similar way as going from the factors to the trinomial. And the executive summary, if you're looking for an executive summary of the AC method, is to multiply a times c, list the pairs of that a times c product, and then rewrite the b term in our original ax squared plus bx plus c as the sum or difference using these, the factors of the AC, a times c product that we've got. And then finally, we've got a factor by grouping. And all these are going to take some time to get through. So if you can get through factoring using this 6.2 or 6.3 method, using the trial and error, it might be better. But let's take a look, before we actually get to the AC method, let's take a look at what we do when we FOIL two factors. So we've got two factors here, and what do we do when we FOIL? We're going to see something that's kind of interesting. So if we take 2x plus 3 times x plus 2, we're going to FOIL. What we do, the first term here is the first terms here multiplied. 2x times x gives me 2x squared. Outside term is 2x times 2 gives me 4x. And again, these are all positive signs, positive, 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 positive. So all these terms down here are going to be positive. So we've done first outside. Inside is going to be 3 plus 3 times plus 2x gives me plus 3x. Last term is going to be plus 3 times plus 2 gives me plus 6. And there's what we've got. When we summarize this, then we'd say, well, you know what, this is not quite mathematically pretty. We've got to kind of combine the like terms. So we combine these like terms to get 7x. And here's what we'd have as a product. So remember, though, in this chapter, so this is pretty much chapter 5. We've taken a binomial times a binomial, did the FOIL method, we got this. We had to summarize like terms, add like terms to get this. So this is chapter 5. Chapter 6 is going to say, you know what, I'll give you this, and I want you to go backwards to get my factors. So I'll give you the product, and now for chapter 6, you've got to go back and find the factors. So what we do with what we did with trial and error was we said, well, we had to factor A, we had to factor C, and we had to set up our little skeleton of our x and put added signs, things like that. With the AC method, we're going to use the idea that we can use, or sorry, we're going to use the idea that we can that we've added the outside and inside terms here, and kind of find a way to split our middle term into these two terms here, and then allow us to go backwards this way by grouping. And this is going to be factoring by grouping. So we'll review that before we get going too. So what do we notice from this polynomial going back to here? Well, we can say that AC, A times C, here's my A is equal to 2, C is equal to 6, positive 2 and positive 6. So A times C is 2 times 6 is 12, and this is kind of the bare bones minimum of, or the first step, I guess, in the AC method is finding A times C. 2 times 6 is 12, and then list the factors of 12. 1 times 12, 2 times 6, 3 times 4, and we can repeat it 4 times 3, but we really don't need to because we've got all factor pairs here. Now we notice that 3 times 4 is equal to our 12 because we've factored 12, and also 3 plus 4 is right here is equal to our 7x. So that's kind of the key to the first step or two in the AC method. So there's an example of what we're doing. So if we're going to write things out and maybe create a cheat sheet study guide, this might be something that you might want to put on it. If we're given ax squared plus bx plus c as a product, as a trinomial, we have to say in chapter 6, factor that for me. Find the factors. Find those parentheses x and parentheses x, kind of like make our skeleton. How do we do that? Well, first step is to make our life easy. Write things in descending order. X squared term has to come first, then the x to the 0 power comes next, or sorry, x to the first power comes next, and x to the 0th power comes next, or last. And that is, again, taking a look at the exponents. 2 is higher than 1 is higher than 0. So write it in descending order, and that will give you a correct A and a correct C, because if you don't write it in descending order, you will not have a correct A and a correct C, and your factorization will be all foiled up. All right, no pun intended. Okay, step number 1A, I guess, or part of making our life easier as well, is factor out a greatest common factor. If we factor out a greatest common factor from ax squared and bx and c, then a and b and c then become smaller numbers that are easier to work with. If we do, please note that if we do factor out a greatest common factor, that greatest common factor is part of the factorization. So that should always be written down here, and then here, and then here if we're factoring down. So make sure that if you factor out a greatest common factor, keep it in the factorization. And then finally, factor out a -1 if a is negative. If that a is negative right up here, then you have to say, I need to factor out a -1 because that will make our life, again, that much easier. Okay, so that's step number 1, is make our life easier. And then 2, 3, 4, and 5 and 6 is basically the essentials of the AC method. Step number 2 is multiply a and c to get AC. Here's our a term, the coefficient in front of the x squared term. The c is just a constant term. In other words, it's c times x to the 0th power, because x to the 0th power is 1. So there's our c. Multiply a and c, and usually we'll write it over on the right side. Step number 3 is list the factor pairs of AC. That's a number, so we'll get a number just like our previous page. We got 12. The factor pairs would be factor pairs that multiply together to give me that a times c. So if our AC was 12, the factor pairs were 1 times 12 gives me 12. 2 times 6 gives me 12, and those would be factor pairs. Step number 4 is find the factor pairs from that list that we just created, which add up to b. Now we'll have to pay attention to negative numbers as well later on, but for the first example, we'll probably just use some positive numbers just to make it easier. So that's step number 4. Step number 5 then is rewrite that middle term, that bx term, in terms of what we just found up here. Those that one factor pair that adds up to the coefficient in the b. So that's what we have to do for step number 5. Step number 6 is factor the polynomial then by grouping. And probably I should write down here, step number 7, check. we should go back from our factorization and double check our work and just make sure that our factorization is correct. So there's our steps. I would recommend writing those down, number one, or number two, maybe printing it out. This is also in the book. If you need to find it in the book, it's I've modified it from page 433. So here is page 433 in our textbook. So you can take a look at that, and if you need to use that as a reference, or print this page out, or print out the notes that are on D2L, or memorize this. And after a while, I think it's going to be something that you'll be able to memorize. So again, here's an example. We've got 2x squared plus 7x plus 6. Coefficients are, and if they're coefficients are a, b, and c, and probably even before we get to here, a and b and c, we should probably try and make our life easy. Number one, do we have to, is it given to us in descending order? It sure is. There's an x to the second power, x to the first power, and x to the 0th power. So it's in descending order. So our a then, in fact, we can't even talk about the a yet. We should probably see if we can factor out a greatest common factor. Can we factor out a greatest common factor from 2x squared and 7x and 6? We can't, because 6 is 2 and 3 and no x's, so there's no x's to factor out. 2 and 3, there's no 3 in 7. So we can't factor out a greatest common factor. And then factor out a -1 from our a term. 2 is positive, so we don't have to worry about that. So now we can come up with our a, which is 2, our b, which is 7, and c, which is 6. So there we go. So that's step number 1. Step number 2 is find the product of a times c. What's a times c? Here's 2, and c is 6. A is 2, c is 6, ac is 12. Step number 3 is find the factor pairs of 12, what we found up here. Factor pairs would be of 12 would be 1 times 12, 2 times 6, 3 times 4, and those all add up to, multiply together to get us 12. These are factor pairs of 12. 1 times 12 is 12, 2 times 6, 3 times 4, and also you could take a look at the negative numbers as well. -1 times -12 gives me 12, and the negative numbers over here as well. But we need to find from this list then, so we've made our list, and step number 4 is find the numbers from these factor pairs over here. Find the numbers from these factor pairs that add up to our b term, 7. 3 plus 4 gives us 7. So that's the factor pair that we're going to use, and we're going to use that to rewrite our original, because I've taken the liberty of copying this, rewriting it down here, and just simply splitting up the 7 into 3x plus 4x, because that's what we need to do. 3 plus 4 gives us 7, and we need to split that up into 3x and 4x. And now, that's our step number 5. We rewrite this 7x to 3x plus 4x. Why do we do that? Because now we can factor by grouping. So let's factor by grouping. If we factor by grouping, we take the first two terms, we group those together, and we take the last two terms and group those together, and we factor each of these pairs. So now we factor the blue pair, and we factor the red pair, and hopefully there's going to be something that's common later on. So let's factor 2x squared plus 3x. What's common? I guess we'd factor out an x. Hang on, we'll make it blue just to be consistent. We'll factor out an x. And what's left over? 2x squared divided by x gives me 2x. Plus 3x divided by x gives me just plus 3. And we can confirm this by going and distributing this x to what's inside the parentheses. X times 2x gives me 2x squared. X times positive 3 gives me 3x. So that's a correct factorization of this blue up here. So now let's go to the red and say I'm going to factor this. How do I factor that? I factor out a common factor between the 4x and the 6. And that would be 2 plus 2. And what's left over? 4x divided by 2 gives me 2x. Plus 6 divided by 2 is plus 3. And now I've factored, and the nice thing is, the beautiful thing is, that we've got now a common factor here between that and that. So now the blue is one term, the red is one term, and now we can say, is there anything, again, this is just common, if this is factoring by grouping. Is there something in this term in blue and that term in red that we can factor out? We can. We can factor out a 2x plus 3. So if we factor out a 2x plus 3, as a complete factor, you put it in the parentheses, what's left over? X times 2x plus 3 divided by 2x plus 3 gives me just x. And then over here, this term here, if we're factoring out a 2x plus 3, 2 times 2x plus 3 divided by 2x plus 3 gives me plus 2. And there's our factorization. And probably we should FOIL, so step number 7 is to use that dreaded F word and FOIL, and let's double check. First term is 2x times x gives me 2x squared. Outside terms, 2x plus 2 is plus 4x. Inside terms, 3 times x is plus 3x. Last terms are 3 times 2 is 6. Combine these two to get me 2x squared plus 7x plus 6 is my correct factorization, because that's what we started with. So this is then our correct factorization, because we've double checked using FOIL, and there's our correct factorization. So that's essentially the AC method. Now, I put this in the blue and the red is my factorization, or my rewriting as 3 and 4 instead of 7. So I took that 7x and wrote it as 3x and 4x. But you know, somebody might say, well, how about if I write it as over here, instead of 3x and 4x, how about if I wrote it as 4x and 3x? Well, to be honest with you, we'll get the same outcome, because when we factor it out, if we factor it out correctly, we will get the same outcome. What we'll do down here is we'll get to factorization like x plus 2 times 2x plus 3. Don't believe me? Do it yourself. Take my word for it. It will work out. We'll do some more examples when we do this. But essentially, this green factorization is the same as this green factorization because of the commutative law of, or property of multiplication. This times this, 2x plus 3 in the front, multiplied by x plus 2 in the back, is the same as 2x plus 3 in the back, multiplied by x plus 2. So it doesn't matter where you put the 3x and the 4x versus 4x and 3x, even if they're negative, doesn't matter. As long as you factor correctly, you'll get to the same spot. All right, let's do one more example, and we'll say, you know what, and I'm going to say, please do me a favor, or do yourselves a favor, pause the video, and for this one, let's use the AC method. And use that AC method that we summarized before. We'll go back over here. Here's our AC method. Make your life easy, multiply A and C, list the factor pairs, which factor pair adds up to B, rewrite the middle term, factor by grouping, and check. So that said, there's a video that you can pause and write down in your shorthand. In fact, for your notes, write down those steps, and then come over here, and you can pause the video as you need. Come over here now, pause the video, and do the work yourself, and see what you come up with for factorization. All right, so I've left a space over here, and I'm going to say, if we're going to factor this out, let's factor by grouping and say, or sorry, not factor by grouping. Eventually we'll factor by grouping, but right here we've got to make our life easy. We've got to say, rewrite this in descending order, or make sure it's in descending order. We've got an x squared term, x to the first power term, x to the 0 term. Great, it's already in descending order. Factor out a greatest common factor, nothing greatest common factor, so we don't have to factor anything out. Step number 1C, the last step, factor out a -1 if that 2 is negative. 2 is not negative, so we don't have to worry about it. It's given to us in an easy-to-use format. All right, step number 2 would be to write AC, and we'll find out what A times C is. Well, in fact, A is going to be equal to 2. C is equal to 3. And you know what? Just for fun, we'll write B here. B is equal to 5. All right, so our AC is 2 times 3 equals 6. All right, well, let's write down the factors of 6. And factors of 6, we've got to find a factor pair of 6 that adds up to 5. Well, it could be 1 times 6, and that would multiply together to get me 6. And if you can go through this two different ways. You can write them all down and then check all of them to see which one is 5, or you can write them all down as you come up with them, and then see if they add up to 6, or sorry, add up to 5, which is our B term. 1 times 6 doesn't equal to 5. Okay, so we can throw that one away. 2 times 3, oh, that does equal to 5. So there's our 2 times 3, and we just rewrite this 5x as something else. We write it as 2x plus 3x. And again, we've got to pay attention to signs. Positive 2 times positive 3 gives us positive 6. Positive 6 can be factored as positive 1 times positive 6. Positive 2 times positive 3, and also negative 1 times negative 6. But you know what? We never got over here because we could stop right here where we find positive 2 times positive 3 gives us a positive 6, and positive 2 plus positive 3 gives me positive 5. So there's what I'm doing. I'm now rewriting 5x as 2x and 3x. And I'll just rewrite now everything else as 2x squared plus 2x plus 3x plus 3. And this has just been rewritten, this has just been rewritten, and 5x is just rewritten as 2x plus 3x. Now we've got to factor by grouping. So we go here and we say, all right, you know what, I'm going to factor these two together because I'm going to factor by grouping. And then I'm going to factor these two together and I'm going to factor by grouping. So let's factor the green ones together. What comes out of 2x squared plus 2x? Well, my greatest common factor I see would be a 2x. So a 2x squared divided by 2x, if we're rewriting this green in terms of our greatest common factor and what's left in the terms, 2x squared divided by 2x gives me just x. Plus 2x divided by 2x is 1. Pay attention to that one. That sometimes trips people up. Sometimes people throw that away because, oh, 2x, I can factor that out and it disappears. It doesn't disappear. You've got to have a place marker there for it because 2x divided by 2x is 1. All right, now we'll factor in red. 3x and 3, what's the greatest common factor between those two? Well, plus 3 is the greatest common factor. 3x divided by 3 gives me just x. Plus 3 divided by plus 3 is, again, plus 1. 3 divided by 3 is 1. It doesn't disappear. It has to still stay there. Now we've got to say, here's a green term and here's a red term. Out of the green term and the red term, what's the greatest common factor? The greatest common factor, I'm going to go back to blue, I guess, is this x plus 1. So the x plus 1 is the greatest common factor between this green term and the red term. So factor out an x plus 1. And what's left over? 2x times x plus 1 divided by x plus 1 gives me, in parentheses, 2x. Same thing holds true over here. 3 times x plus 1 divided by x plus 1 gives me plus 3. And that should be my factorization. And the nice thing is, you've come up with x plus 1 and x plus 1 in both of those green and red terms of this polynomial, because this is now just a binomial, because there's one term here and one term here. That means that this factor, x plus 1, is common to them, and you can factor that out. When you see this and this, you've gotten, you're probably on the right path. Just make sure that you can, I guess, double check your factorization. 2x times x gives me 2x squared. 2x times 1, 2x. 3 times x, 3x. 3 times 1, 3. Okay, good. Now we really should do our double check and say, let's FOIL this out and say, does it work? X times first terms, x times 2x is 2x squared. Outside term, x times 3 is plus 3x. Inside term, plus 1 times 2x is plus 2x. Last term, 1 times 3 is plus 3. And then combine these terms to get 2x squared plus 5x plus 3. And is that the same as what we started with? 2x squared plus 5x plus 3? It is. So we've done our FOIL to double check our work. And there's our correct factorization then. All right. That said, I'm going to set you free on doing this one here for your homework. Let's do this one, because you've taken notes already, and you've got to make sure that you put that in the Dropbox. So let's go here and say, for your homework, let's do that one. Do that one. Make sure you go through all the steps that you've written down before. Let's see, there's homework right there. Do that for the homework. Take your notes, take a picture, add that this factorization here to your notes, and put it in my Dropbox. Just a note about this one, a caveat, a warning. Make sure that you go through making your life easy steps. Step number 1, to make sure that you've got the correct A, and the correct B, and the correct C. All right, we'll see you in class.